Hello students, I hope you are all doing well during this pandemic. Stay safe at home and be careful whenever you go outside and wash your hands with the sanitizer. Now, let us just start with few more examples on 1, onto as well as bijective function. Now, first of all, before starting the example, let us just recall what is 1, onto and bijective. 1 function is nothing but when we consider a function, the elements in the domain must be related to unique element. If the elements in domain are related to same element in codomain, that is, two different elements are having same image. In that case, the function is not 1, it is called many one, because 1 means one element, one unique image. Many one means many elements are having same image. And the next one is onto. What is onto? Here we have to consider the elements in codomain. If each and every element in codomain is related to one or other element in the domain, then it is onto function. Or in other words, when we solve the example, we are using most convenient method, that is, codomain should be equal to range of the function. Range is the set of all images of the given function. And if codomain and range both are equal, then it is called onto function. And when we are having a function f from x to y, you may say, where x and y are the non-empty sets, in that case, the function is 1, and onto. Both 1, and onto. Then it is called bijective. Suppose the function is 1, but not onto. Or the function is onto but not 1. In both the cases, the function is not bijective. So remember, the given function is bijective if and only if the function f is 1, and onto. Now let us start with few more examples. Already in the last class we have studied what is the different types of functions, and also we have checked the conditions for modulus function as well as greatest integer function. As we have studied, the modulus and greatest integer functions both are not bijective. Now let us consider the next one. Show that the signal function f from set of reals to reals defined by f of x is equal to minus 1 if x is less than 0, it is equal to 0 if x is equal to 0, and it is equal to 1 if x is greater than 1, is neither 1 nor onto. Already in the exam, the question only they have given. We have to prove the function, signal function is neither 1 nor onto. Neither 1. So how to prove this? Neither 1 or not 1 means the function is many 1 here. Or directly we can say, look at the definition, x less than 0. Less than 0 means the real values are negative. Whenever we are taking any negative real number, its image is minus 1. If the real number value is 0, then the image is 0. If the taken number, real number is greater than, here it is greater than 0. Greater than 0, then the image is always equal to 1. So here, for 1 function, let us consider two real numbers. Let 1 and 2 belongs to the domain R. F of 1 is equal to 1 is greater than 0. So according to the definition, its image equal to 1. And 2 is also greater than 0. So f of 2, image of the element 2 under the given signal function is equal to 1. Both 1 and 2 are having the same image 1. Therefore, f of 1 equal to f of 2, but 1 not equal to 2 implies f is not 1. Because you may say different elements are having the same image, that's why the given function is not 1. The next condition is onto. How to check whether the given function is onto or not? It's very simple. Just we will compare the codomain and range of the function. Already we have studied what is range. It is set of all images. Images are here -1, 0 and 1. That means codomain being set of real numbers and range is a set containing -1, 0, 1. Both are not at all equal. Here, range of the function is set containing -1, 0, 1. Implies range not equal to codomain. That is, f is not on. So easily we can satisfy or easily we can prove the given signum function is neither 1 nor onto. And also you may write the conclusion it is not bijective. Now let us move to the next example. In the next question also we have to check the injectivity and surjectivity of the function. In the following examples, check whether f is 1, 1 onto or bijective. So in the given examples here we have to check for on one condition or onto condition. If both it is both 1, 1 and onto, then we can conclude it is bijective. So the first question is a function f defined from set of reals to real defined as f of x is equal to 3 minus 4x. F is a function defined in the set of real numbers and the definition of the function here is f of x is equal to 3 minus 4x. Now let us take the solution. F of x is equal to 3 minus 4x. F of x is equal to 3 minus 4x. So we are using the contrapositive method to prove or to check whether the given function is 1, 1 or not. So what we do? Let x, y belongs to the domain R such that f of x is equal to f of y. That means when you substitute in place of x, y, we will be getting 3 minus 4y. So according to the condition here, f of x is 3 minus 4x and f of y is 3 minus 4y. And cancelling the constants, we will get minus 4x is equal to minus 4y, or dividing both sides by minus 4 we are getting x is equal to y. Therefore, f is 1. Now how to check the function is onto or not? So for that purpose what we do? We will take one random variable or a random number in codomain and we will check whether that random element in codomain whether it has a pre-image or not in W. So for onto condition, let y belongs to codomain such that f of x is equal to y where x belongs to domain. F of x is equal to y, but what is our f of x? It is 3 minus 4x equal to y. Now what we do? Using this definition, we will express x in terms of y. So for that purpose, we will shift all other constants except this x or other constants to other side. So what happens here? It will be minus 4x is equal to y minus 3 implies we need only x in LHS, so we will divide both sides by minus 4. So what happens then? X is equal to minus 4x by minus 4 is x is equal to y minus 3 divided by minus 4. Y minus 3 divided by minus 4, or we may rewrite taking this negative sign above. So what happens? It will be 3 minus y divided by 4. This is the value of x. Now we need to check whether this value of x belongs in domain or not. So we will consider f of x is equal to y, no doubt at all. But in place of x, what we will do? We will substitute the value 3 minus y divided by 4. F of x is equal to 3 minus 4x, that is equal to 3 minus 4 into, in place of x, substitute this 3 minus y divided by 4. 3 minus y divided by 4, that is 3 minus, what happens? We will have to take the elements outside the bracket. So it is minus 4 into 3 is minus 12. Minus of minus becomes plus divided by 4. Or in other words, we may do one thing. We will keep this negative sign outside only first of all. Then 4 into 3 is 12 minus 4 by we will write. When we take the terms outside the bracket after taking the LCM, we will simplify. So what happens here? Now we can't directly cancel. So we will be taking the LCM. 4 is the LCM. 3 into 4, 12. Let us take the elements outside the bracket. Minus 12 minus of minus becomes plus 4y divided by 4. 12 minus 12 cancels. 4y divided by 4 is equal to y. So f of x is equal to y we are getting. That means the value of x, that is x is equal to 3 minus y divided by 4, belongs to the domain. Implies for a random element in codomain, there exists a pre-image in domain. Therefore, we may conclude the function f is onto. Therefore, f is onto implies f is bijective. Why we are writing f is bijective? Because already we have proved the function is 1, 1 and the function is onto, and hence the function is bijective. So I hope you understood this concept, because when we are solving the problems we will have to prove in general. Only when we are proving the function is not 1, 1 or not onto, we can give certain examples. Now let us consider the next question. The same heading here. In the following example, we have to check whether the function is 1, 1, onto or bijective. So here the function f is defined from set of reals to reals as f of x is equal to 1 plus x square. F of x is equal to 1 plus x square. Now, in this example, the function f is defined from R to R as 1 plus x square. Here also we have to check whether f is 1, 1 or onto. So, how to do that? As we have solved the previous example, in the same way we will have to solve this also. So, we will consider the 1, 1 condition first of all. So, what we do here? Let x and y, we will consider two numbers or two arbitrary elements belonging to the domain set of real numbers such that f of x is equal to f of y. Implies f of x is 1 plus x square equal to f of y, means in place of x you have to substitute y, so it is 1 plus y square. Now first of all we are cancelling the constant, implies x square equal to y square. But when we simplify this further, as we have already solved in an example, or in other words we may say taking square roots on both sides, already we know we will be getting x is equal to plus or minus y. That means x may be equal to plus y or x may be equal to minus y. X is equal to y, it's not a problem, but when the same element x is equal to minus y as well as y, implies two different elements are having same image. Therefore, the function is not 1, 1 because different elements are having same image. Or in other words also we may say f of 1 is also equal to 1 plus 1 square is 1, 1 plus 1 equal to 2, and f of minus 1 is 1 plus minus 1 the whole square. Minus 1 the whole square is 1, so 1 plus 1 we are getting same image. Image is 2, but the elements 1 and minus 1 are not equal. Therefore, f is not 1. Now how to prove whether the function is onto or not? How to check that? Already we have solved an example in the previous question. The same method we will have to use now also. So what we do, we take one arbitrary element in domain and we will check whether the elements will be there or not in the domain. Now, but if you go with that method, it will be little bit lengthy. So we will just consider the another method which we have used while solving or while checking the injectivity and surjectivity of modulus function, greatest integer as well as signum function. That is to find the range of the function, and afterwards we will just compare the range and codomain of the function here. For onto condition, f of x is equal to 1 plus x square, and x is nothing but an element in domain of the function, that is set of real numbers. Clearly we can write x belongs to R implies x square is greater than or equal to 0. Right? X is a real number, but when we consider square of any real number, it will be non-negative. Either it is equal to 0 if the number is 0, or its square is always positive. So x square is greater than or equal to 0, but in the function we are having 1 plus x square. So what we do, we will add 1 both sides. So 1 plus x square is greater than or equal to 1. This 1 plus x square is nothing but f of x is always greater than or equal to 1. Implies f of x belongs to closed interval greater than or equal to closed interval 1 to infinity. Or in other words we may say 1 plus x square is always positive. Range is equal to closed interval 1 to infinity, which is not equal to codomain R, because set of real numbers is nothing but minus infinity to infinity. Therefore, f is not onto. The given function is neither 1 nor onto. So we cannot say or we cannot conclude the function is bijective, because it is both neither 1 nor onto. Now let us move on to the next example. In this function, we will be considering, let f is a function defined in the set of natural numbers defined by f of n is equal to n plus 1 divided by 2 if n is odd and it is n by 2 if n is even. So here the function is defined for both odd natural numbers as well as even natural numbers. If the number is odd, then the image, or you may say the definition we are going to use is n plus 1 divided by 2. If the number is even, then we are using n by 2. Check if f is 1 odd onto. So here we have to check whether the given function f is 1 or the function f is onto. So now what we do, we will consider the definition of the function. F of n is odd number, n is even number. In both cases we will have to check and we have to check whether the different elements are having same image or different images. Now, just we will consider, in general when we look at the question, or in general when we look at the definition, we may think the function is 1 1 because it is having different definitions. No doubt, if you are taking only odd numbers, we may get the different image. But when we take odd number as well as even number together, what happens we have to check. Let us just take two odd numbers, 1 and 3. F of 1 means 1 plus 1, that is 2 by 2 is 1. When we consider n is equal to 3, 3 plus 1 divided by 2 means 4 by 2, that is equal to 2. So elements are different, images are different. Similarly, we can say for the even numbers separately, taking separately. But when we take one even number and one odd number, what happens? What happens then? Let us take the examples. 1 and 2, both are natural numbers. 1 plus 1 is 2, 2 by 2 is equal to 1. So the image exists. But when we take the another number as 2, 2 by 2, we have to use this definition because 2 is even. 2 by 2 is 1. 1 and 2 both are different, but the images is equal to 1. That means the function is many 1, not 1 1. So the same example we can provide to prove the given function is not 1 1. Let 1 and 2 belongs to set of natural numbers. F of 1 is equal to, 1 is odd number, so we will have to use this definition. 1 plus 1 divided by 2, that is 2 by 2 equal to 1. And f of 2 is equal to, f of 2, 2 is even number, so the definition is n by 2, that is 2 by 2 equal to 1. Implies f of 1 equal to f of 2, but 1 not equal to 2. Implies f is not 1 1. Already we have discussed, only for one element or two elements the condition is not satisfied, then also the function is not 1 1. The next condition is onto. How to check whether the function is onto or not? So in this case what we do, we will have to prove the codomain. The codomain is equal to range, or in other words we may say the random element which we take in codomain, it has a pre-image in its domain. Now what we do, we will consider a random element as n, or you may take the random element as r also, and we will have to check whether that element has pre-image or not. But be careful, when we take the elements in codomain n, that is set of natural numbers, we are taking both even numbers as well as odd numbers, because here we are having different definitions. So let n belongs to codomain n where n is odd. That is, n is equal to, n is odd, n is equal to 2r plus 1, where r belongs to, or r is any natural number. N is equal to 2r plus 1. Why I am writing n is equal to 2r plus 1? Because when we consider even numbers or odd numbers, the basic concept we are using, whether the given number is divisible by 2 or not. If the number is divisible by 2, it is even. If the number is not divisible by 2, then it is odd number. So whatever is the value of r, 2 into r means multiple of 2, hence it is even, plus 1 or minus 1 we may say. In that case, the number will be obviously even, odd. So n is equal to 2r plus 1, where r is a natural number. I am taking an odd natural number in codomain and have to check whether that number has a pre-image in the domain or not. So what happens? N is equal to 2r plus 1 such that I will write f of n is equal to, n value is 2r plus 1, and n, as we have discussed, we are taking as an odd number. When n is odd, what is the definition? we have to use this definition. In place of n, I have to substitute the value 2r plus 1. So n is equal to 2r plus 1. Or we may say f of n is equal to 2r plus 1 divided by something. So in order to make it more clear, what we can do is n is equal to 2r plus 1 belongs to r. Let us take this is our element in domain. Then what we will do, whether the domain element, this element in domain has an image or not in codomain, we will check. So what happens here? F of 4r plus 1, n is equal to 2r plus 1, and here we are considering f of 4r plus 1. 4r, this is also multiple of 2 only. So obviously 4r plus 1 is even number or odd number. Obviously it is odd number. So what happens according to the definition? If n is odd, n plus 1 divided by 2. So 4r plus 1 becomes 4r plus 1 divided by 2. That is 4r as it is. 1 plus 1 is 2 divided by 2. Divide both the numbers by 2. So 4r by 2 means 2r plus 1. And this element belongs to the element in domain. 4r plus 1 is our element in codomain, and this 2r plus 1 is our element in domain. Also, if n is even number, then for 2r in the domain, what happens? Or for 2r in the codomain, we will consider f of 4r. Obviously 4r is a multiple of 2, hence it is even. So when the number is even, we will be using the definition n by 2, that is 4r by 2, which is equal to 2r, belongs to the codomain. So whenever we are taking odd number or even number in the domain, there exists an image, in codomain. Or in other words, or you may say conversely, we may also say for each and every random element in codomain, there exists a pre-image in domain. Therefore, f is onto. So just compare the previous example and this one. In that example, the function is both 1, 1 and onto, but here the function is not 1, 1, but it is onto. It is not 1, 1, but onto. So we can't conclude the function is bijective. So the condition for injectivity doesn't hold, but subjective condition holds good in this example. Now let us move on to the next question. In this question, we are defining two sets A and B as A is equal to R minus singleton set 3 and B is equal to R minus singleton set 1. That means set A is nothing but set of reals only, but the element 3 is not there. And set B is a set of reals where element 1 will not be present. And afterwards we are considering a function f from A to B such that f of x is equal to x minus 2 divided by x minus 3. F of x is x minus 2 by x minus 3. Here, look at the definition of the function. In place of x, if you substitute 3, the function will not be defined. That's why domain doesn't contain the element 3. Now, we have to check whether the function f is 1, 1 and onto. So, as we have discussed in the previous examples, here also we will consider the same thing. So, what we do? In this question, f of x is equal to x minus 2 divided by x minus 3. For 1, 1 function, we need to check whether different elements are having different images or not. But whenever we are solving the problems, we are using the contrapositive method. So, let x1 belongs to A. Domain is nothing but set A here, such that f of x is equal to f of y. So f of x is x, that implies x minus 2 divided by x minus 3 equal to f of y means replace x by y minus 2 divided by y minus 3. Now in this one what we have to do? We will cross multiply and afterward we will check whether x is equal to y or not. So it will be x minus 2 into y minus 3 equal to y minus 2 into x minus 3. Term by term multiplication. So we will be getting xy minus 2y minus 3x minus of minus becomes plus 6 equal to xy minus 2x minus 3y plus 6. So 6 we are having on both sides with the same sign we can cancel. Xy is also common, easily we can cancel. So we are having minus 2y minus 3x equal to minus 2x minus 3y. So what we do? We will shift the terms containing x to one side and the terms containing y to one side. So minus 2y will be shifting. So minus 3x minus, already it is a Hegde sign, when we shift it to LHS becomes positive, plus 2x equal to minus 3y plus 2y. Minus 3x plus 2x is nothing but minus x. Here we will be having minus y, that is x is equal to y. Therefore f is 1. F of x is equal to y we are considering, and after some simplification we are getting x is equal to y. So the images are same means elements are also same. Hence the function is 1. Now the next condition, we need to check whether the function is onto or not. So in this example we have to be very careful, because as we are having numerator and denominator, if you miss a single sign, it may lead to confusion at the end while solving the problem. So for onto condition, let y belongs to b. B is nothing but our codomain, such that f of x is equal to y, where x belongs to a. Now f of x equal to y, f of x is x minus 2 divided by x minus 3 equal to y. We need to express x in terms of y, so we will cross multiply and then simplify for x. X minus 2 is equal to y into x minus 3, that is nothing but xy minus 3y. Shift the terms containing x to LHS and other terms to RHS here. So it is x minus xy is equal to minus 2 initially, but when we shift it to RHS becomes positive. X minus xy is equal to 2 minus 3y. Or you may say, taking x outside, we are left with 1 minus y. It is 2 minus 3y. Or x is equal to 2 minus 3y divided by 1 minus y. Now look at the value. Y is an element in codomain and 1 minus y comes in the denominator when we solve for x. So if y is equal to 1, the value of x doesn't exist. That's why the codomain doesn't contain the number 1. Now x is equal to 2 minus 3y divided by 1 minus y. What we do? We need to check whether this value satisfies the condition f of x equal to y or not. So what we are doing? We consider f of x, that is f of x is equal to f of, so what is the value of x? Substitute 2 minus 3y divided by 1 minus y. Now f of x, in place of x we are putting 2 minus 3y divided by 1 minus 1. But what is f of x using the definition? It is x minus 2 divided by x minus 3. Now in this place of x, we have to substitute this whole value. So that is x minus 2, but x is this thing, 2 minus 3y divided by 1 minus y minus 2 whole divided by x minus, again 2 minus 3y divided by 1 minus y minus 3. So what happens now? We have to take the LCM and simplify. When we take the LCM, what happens? 1 minus y is the LCM both in the numerator as well as the denominator. So once we take the LCM, we can cancel. So it is 2 minus 3y minus 2 into 1 minus y whole divided by 2 minus 3y minus 3 into 1 minus y. Now, that is equal to, here already we have taken the LCM and cancelled the denominator. This is the simplified version. I have skipped one next step here. So it is 2 minus 3y term by term multiplication minus 2 minus of minus plus 2y divided by 2 minus 3y minus 3 minus of minus becomes plus 3y. Right? Now, what we do? 2 minus 2 gets cancelled. Minus 3y plus 2y is minus y. In the denominator minus 3y plus 3y gets cancelled. 2 minus 3. Minus 3. 3 is having negative sign and 2 is having positive sign. It is minus 1. That is f of x is equal to 1 reality. So that value of x, that is 2 minus 3y divided by 1 minus y, satisfies the condition f of x is equal to 1. Therefore, f is onto. The function is both 1, 1 and onto. Hence, we may conclude f is bijective. This is for today's class. I hope you have watched all the videos, because if you miss a single video, then it will be very difficult to understand the upcoming classes. And I hope after watching the video, you remember what you have to do. That is, you have to put your name and section in the comment box. And please watch all the videos. Don't